Hey guys, welcome to TechLingo. In this video, I'm going to show you how you can create a new vSAN cluster while deploying a vCenter server appliance. So typically a vSAN cluster is created after the vCenter server appliance has been deployed and configured. But for the environments where vCenter server is not installed, you can create a new vSAN cluster as you deploy the vCenter server appliance and host that vCenter server on the same vSAN cluster. In other words, you don't need to have an already installed vCenter server to create a new vSAN cluster. While deploying a new vCenter server, you can create a new vSAN cluster with just a single ESXi host, and you can have the disks claimed from that host for the vSAN data store. So in this video, like I said, I will discuss on how to deploy vCenter Server 6.7 Update 3 and create a new vSAN cluster at the same time. So I'll be deploying vCenter Server appliance with embedded PSC. But before that, let's take a look at my lab environment. And before I show you my lab setup, this is the step in the deployment wizard, which will allow you to create a new vSAN cluster while deploying the vCenter server appliance. You can see in this screenshot, selecting the option install on a new vSAN cluster containing the target host will allow you to create a vSAN cluster and specify the data center name as well as the cluster name. In the next step, the wizard allow you to specify the disks that can be claimed for caching tier as well as the capacity tier to contribute to the vSAN data store. Although the vCenter server appliance will help you to create a new vSAN cluster, deploy a vSAN data store, and store the vCenter server appliance in the same vSAN data store, you will still need to complete the remaining configuration of the vSAN cluster, such as adding additional ESXi hosts to the vSAN cluster, configuring vSAN storage and networking soon after the deployment of vCenter server. So coming to my lab environment, I have a standalone ESXi host, which is a desktop with 64 gig of RAM and a Core i5 processor and a 500 gig of SSD disk and also a 1 TB of regular magnetic disk. But for my lab environment, I'll be using the SSD disk to save my virtual machines. So with the help of virtualization, I have hosted my 3-node ESXi hosts as virtual machines. This lab environment is no way a recommended setup for production environment, but this environment can be used for lab purpose only. So here are the three virtual machines which I have created using ESXi 6.7 update 3, ESX01, ESX02, and ESX03. Like I said, they are running ESXi 6.7 update 3, and they have 4 gig of CPU and 16 gig of RAM. Each virtual machine that runs as ESXi hosts has 5 virtual disks. Hard disk 1 is a 5 gig thin virtual disk which is saved in my 500 gig SSD disk, and this 5 GB virtual disk is used for ESXi operating system. Hard disk 2 is a 20 gig SSD disk which is thin provisioned, and it is also saved in my 500 gig SSD disk on the ESXi host. And hard disk 2 will be used for caching tier, and the next three hard disks are 200 gig in size, and they're also thin disk and also saved in my 500 gig SSD disk. And these three virtual disks will be used for capacity tier. Each ESXi host which are running as virtual machines has 8 network adapters. So the first two network adapters are connected to my management network. Network adapter 3 and 4 are connected to vMotion network. Network adapter 5 and 6 are connected to vSAN network. Network adapter 7 and 8 are connected to my virtual machine network. Along with these three virtual machines, I've also created two more virtual machines, DC01 that acts as the domain controller and the DNS server for my Active Directory domain contoso.local, and router01 that acts as the gateway appliance for the virtual networks which I've created on my standalone ESXi host. So DC01 is running Windows Server 2019, and it has a single network adapter which is connected to my management network. Coming to router 01, it is also running Windows Server 2019 and it has 5 network adapters. Network adapter 1 is connected to my management network. Network adapter 2 is connected to vMotion network. Network adapter 3 is connected to vSAN network. And network adapter 4 is connected to virtual machine network. Network adapter 5 is connected to internet. So these network adapters of router VM acts as the gateway IP for these respective networks, right? So if I log into this router 01 VM and if I go into the network settings, you can see all these 5 network adapters. And for management network, the IP address which I've configured is 192.168.10.254 and it's a class C subnet. And for vMotion network, the IP address configured is 192.168.11.254. For vSAN network, the IP address configured is 192.168.12.254. For VM network, the IP address configured is 192.168.13.254. And for internet, it has the IP address configured in the internet IP subnet. So I'll click close. So these network adapters acts as the gateway for their respective networks. And here is the networking overview of my standalone ESXi host for this lab environment. So these networks are actually the standard switch port groups. For this lab, I have created 2 standard switches, DC01 and vSwitch 0. And DC01 has no uplinks, whereas vSwitch 0 has one uplink, which is connected to my external network for internet. So if I open DC01, it has 4 virtual networks. Management network DC01, which is in the subnet of 192.168.10.x/24. NIC1 and NIC2 of the ESXi hosts are connected to this management network, and NIC1 of router 01 and DC01 are also connected to this management network. We have vMotion network DC01 port group, which is in the subnet of 192.168.11.x/24. NIC3 and NIC4 of all the ESXi hosts are connected to this vMotion network, and NIC2 of the router 02 is also connected to this vMotion network. Next, we have vSAN network, which is in the subnet of 192.168.12.x/24. NIC5 and NIC6 of the ESXi hosts are connected to the vSAN network, and NIC3 of router 01 is also connected to vSAN network. And finally, we have VM network, which is in the subnet of 192.168.13.x. NIC7 and NIC8 of the ESXi hosts are connected to this VM network, and NIC4 of router 01 is also connected to this VM network. And the virtual switch vSwitch 0, it has a port group called internet, and it has a single uplink used for internet connectivity. So NIC5 of router 01 VM is connected to this port group for internet connectivity. This single uplink is connected to my home broadband network. So before we start creating a vSAN cluster, we must ensure that the ESXi host's hardware components are compatible with VMware HCL. But here are some of the key points to consider before creating a vSAN cluster. Now, this list is not a complete list for vSAN prerequisites. If you want a complete list of vSAN prerequisites, you can go to VMware documentation and look for vSAN prerequisites. Coming to cluster requirements, the vSAN cluster must contain a minimum of 3 ESXi hosts or 2 ESXi hosts if vSAN Witness appliance is being used. In my lab demo, I'll be using 3 ESXi hosts to build the vSAN cluster. So these ESXi hosts must contribute storage from their local disks, and a minimum of 4 disks must be contributing to the vSAN data store. And in that 4 disks, at least one of them should be SSD disk for caching, and remaining disks can be capacity disk. And these ESXi hosts, which are already a member of a vSAN cluster, cannot be a member of other vSAN or HA clusters. Coming to the networking requirements for hybrid vSAN configuration, a minimum of 1 gig network adapters are recommended for vSAN traffic. But for all flash vSAN configuration, a minimum of 10 gig network adapters are recommended for vSAN traffic. I'm using 1 gig network adapter for vSAN traffic, and it is completely okay for lab purpose. The ESXi hosts must be connected to a layer 2 or a layer 3 vSAN network. All my ESXi hosts are connected to same layer 2 vSAN network. And each ESXi host participating in the vSAN cluster must have a dedicated vSAN VM kernel port, regardless of whether it contributes storage. These vSAN VM kernel ports will be created for one ESXi host while deploying vCenter server appliance. Coming to storage requirements, minimum of one SSD or PCIe flash device should be available for caching tier. In hybrid vSAN configuration, minimum of one magnetic disk should be available for capacity tier, wherein all flash vSAN configuration, minimum of one SSD or PCIe flash device should be available for capacity tier. If you are using SAS or SATA HPA or RAID controller, you need to configure non-RAID pass-through or RAID 0. If the ESXi host is booting from the USB or SD card, then the size of the disk must be at least 4 GB. If the ESXi host is booting from the SATA DOM device, you need to use a single level cell device, and the size of the boot device must be at least 16 GB. Now for this lab demo, each ESXi host, like I said before, has 5 disks and all of them are SSD disks. And that means I'm going to build an all-flash vSAN cluster. After ensuring that all the prerequisites are met, the first step is to deploy the vCenter server appliance with an embedded PSC. And at the same time, we'll be creating a new vSAN cluster. So I've already mounted the VCSA ISO image. So I'm going to launch the installer file, which is in the directory VCSA UI installer Win32. And I will double click on this installer.exe. I'll click on install, which will install a new vCenter server appliance. And I'll click next on the introduction page. In the end user license agreement, I will click on I accept the terms and I'll click next. And for the deployment type, I'm going to select vCenter server with an embedded PSC and I'll click next. For the ESXi host of vCenter server name, I'm going to specify my first ESXi host, which is esx01.contoso.local, and I'll specify the root credentials for my ESX01. I'll accept the self-signed certificate. Now I'm going to give a name for my vCenter server appliance, which will show up in the inventory. So the name will be vCenter01, and I'll specify the root password for this appliance. And in the deployment size, I will keep this default. Let this be tiny, and the storage size will also be default. So I'm going to click next. So here I need to select the second option that says install on a new vSAN cluster containing the target host. So selecting this option will create a new vSAN cluster while deploying a vCenter server appliance. And you can also specify the data center name. So for the data center name, I will specify Contoso as the data center name, and the cluster name will be HA cluster, and I'll click next. So in the claim disks for vSAN, you need to select the disk which will be used for caching tier and the disks which will be used for capacity tier. So like I said before, in this lab demo for my ESXi hosts, I will be using 20 GB disk as the caching disk, and it is already selected for caching tier, and the other 200 GB disks will be used for capacity tier. So I will select the 200 GB disks and I'll click on claim for capacity. All right, so we have three 200 GB disks which will be used for capacity tier, and one caching disk which is a 20 gig disk which will be used for caching tier. And I'll also enable thin disk mode, and I'll click next. So in the configure network settings screen, you have to configure the network settings for the vCenter server appliance. So in the network, so you have an option to specify the network that will be used by VCSA. And you can see there's only one network, VM network, because this appliance is being deployed onto an ESXi host, which has the only one default VM port group, VM network port group. And this network for vCenter appliance can always be changed later. And I'll keep the IP version as IPv4 and the IP assignment will be static. And for the FQDN, I'm going to specify the fully qualified domain name for the VCSA, so which will be vcenter01.contoso.local. And the IP address is 192.168.10.11, which will be the IP address for this vCenter server appliance. And I've already pre-staged the DNS entry for the vCenter server appliance in my DNS server. And the subnet mask will be 255.255.255.0. And the default gateway will be the gateway address for this network, which is 192.168.10.254. And the DNS server will be my single DNS server, which is 192.168.10.1. And I'll leave the default HTTP and HTTPS ports, and I'll click next. Okay, so now at this point, you can review your settings and click on Finish to start the deployment of the appliance. And you can see the deployment progress of the VCSA. All right, so the stage one of the deployment has completed. So you can click continue to proceed to the stage two of the deployment. Now, if you click close and close this installer, you can resume the appliance setup at any time by logging into the vCenter server WAMI page using the root credentials. I will click continue. All right, so we are in the stage two of the deployment process where the VCSA will be configured. So I'm going to click next on the introduction screen. For the time synchronization mode, I will synchronize the time with my NTP server, which is actually my domain controller, which is 192.168.10.1. And I will keep the SSH access enabled, and I'll click next. I will click OK on the IP address change warning dialog box. All right, in the SSO configuration screen, you can either select to create a new SSO domain or join an existing domain. Since it's my first vCenter server appliance which is being deployed, I'll keep the option create a new SSO domain selected. And for the SSO domain name, I'll type the default domain name, which is vsphere.local. And for the SSO admin account, I will type in the password and I'll confirm it again and I'll click next. And in the configure CEIP screen, I will uncheck join the VMware's customer experience improvement program and I'll click next. All right, you can review the settings and click finish. I will click on OK on the notification that says you will not be able to pause or stop the installation. And you can view the progress of the stage 2 deployment of VCSA. All right, the stage two deployment has completed and ensure that the setup has completed successfully. And in the same window, the wizard will provide you a URL to log into the vCenter server. So I'm going to click that link to log into the vCenter server. I'll click Advanced and click Proceed to the vCenter Server Appliance login page. I'll click on Launch vSphere Client HTML5 and I'll type the default SSO admin user and the password and I'll click Login. So after you log into vCenter Server, you'll see a data center and a vSAN cluster with single ESXi host hosting the vCenter Server appliance that we just deployed. So in my case, I can see the data center name Contoso and the vSAN cluster name is HA cluster with my single ESXi host ESX01 already being the member of the cluster. Since the vSAN configuration is incomplete, I'm seeing these alarms with my vSAN cluster. So to complete the configuration of the vSAN cluster, I need to add the remaining vSAN hosts to the cluster. So for this vSAN cluster, I'll be adding other two ESXi hosts, ESX02 and ESX03, and I'll configure a distributed switch and add the vSAN VM kernel adapter for 3 ESXi hosts. And I will also add the cache disk and the capacity disks from the other two ESXi hosts to the vSAN disk group. And lastly, I will apply the vSAN default storage policy to the vCenter server appliance. So there's a feature in vSphere cluster called Configuration Assist, which will help you to complete the necessary steps which I talked about, such as creating the distributed switch, VM kernel adapters for vSAN traffic and vMotion traffic. So Configuration Assist, you can find it in HA cluster and clicking Configure and clicking Quick Start under Configuration. So it's a feature not just reserved for use with easy install based deployments. You can also use when configuring the existing vSAN cluster. So this has that deep integration into vSAN. So it will help you to make sure that your vSAN cluster is healthy. So you'll see three tabs: cluster basics, add hosts, and configure cluster. So I'm going to click edit under cluster basics. So in the edit cluster settings window, you can specify the name of the cluster. So I'll keep the name which I specified during the deployment of the vCenter server appliance. And you can enable or disable vSphere DRS, vSphere HA, and vSAN. So here the vSAN services is already enabled. So I'm going to enable vSphere DRS as well as vSphere HA, and I'm going to click OK. All right, now under cluster basics, you can see vSphere DRS and vSphere HA is enabled and you have a green check mark. Now under add hosts, I will click on add to add the remaining hosts. Under add hosts, I will click on add to add the remaining two hosts. In the add hosts screen under new hosts, you can either type the FQDN or the IP address of the remaining two hosts. In my case, I will type the FQDN of the hosts and I'll specify the root credentials for these hosts. If I check this option, use the same credential for all hosts, then I don't need to type the same root credentials again for all the hosts if the root credentials for those hosts are all same. For this vSAN cluster, I will add ESX02 and ESX03, and I've already created the DNS entries for them in my DNS server. So I'm going to click next. And I'm going to accept the default certificates of the hosts by clicking OK on the security alert. In the host summary screen, you can review the host summary details and click next. In the ready to complete screen, the wizard will display the message about the new hosts that will be added to the vSAN cluster. And these hosts will enter into maintenance mode, for which you might need to power off or migrate any VMs, if any. In my case, I don't have any VMs running on these two hosts. Since these are new hosts, I will simply click Finish to add the two hosts. After adding the new hosts, they will continue to stay in maintenance mode until you configure the storage and networking. Now the next step is to configure the storage and networking for the vSAN cluster. So I will click Configure under Configure Cluster. In the distributed switches screen, I will specify 1 for the number of distributed switches required, which will create one distributed switch. If you wish to configure the networking settings later, you can select the option Configure Networking Settings Later. In our case, we'll create a distributed switch and use the default name, which is dswitch. And if you have an existing distributed switch which you would like to use, you can click the link that says use existing. In my case, I don't have any existing DV switch. Now this wizard will only create two DV port groups, one for vMotion traffic and another one for vSAN traffic. Now under port groups, you can see two port groups named dswitch vMotion and dswitch vSAN, and both of them are attached to the dswitch distributed switch. And under physical adapters, I have 8 physical adapters on each ESXi hosts. And I'll connect only VMNIC2, VMNIC3, VMNIC4, and VMNIC5 to the distributed switch D switch. Now VMNIC 0 and VMNIC 1 is being used for management network, which is created by default standard vSwitch. Now after the creation of this distributed switch using this quick start wizard, I'm going to go ahead and migrate the VM kernel adapter and the physical adapters used by management network from my standard switch to the distributed switch. And likewise, I will create virtual machine network port groups using VMNIC 6 and VMNIC 7 after completing this quick start wizard. Now, this is my type of lab setup where I have created a pair of network adapters for each type of network. But typically in a production environment, you would see a pair of 10 gig or higher network adapters carrying all traffic using VLAN IDs for segmenting different types of traffic. By the way, the wizard will not complete all the required networking configuration for your environment. This wizard will help you to set up the initial vSAN configuration. Okay, so after making the appropriate selection, I will click Next. All right, now in the vMotion traffic screen, you can check the option Use VLAN if you want to specify the VLAN ID for vMotion traffic. But in my lab, there's no VLAN ID for any traffic, so I'm going to uncheck the Use VLAN option. And I'll keep the IP protocol as IPv4. And under IPv4 configuration for the IP type, I will select static IPs and specify the IPv4 address, subnet mask, and the gateway for the vMotion VM kernel adapter on all three ESXi hosts. You can see my vMotion subnet is 192.168.11.x/24, and the gateway IP is 192.168.11.254. You can click on autofill to fill the vMotion IP address for all the three hosts, but in my case, it is not continuous. So for my ESX01, the vMotion IP address is 192.168.11.21. And for my ESX02, the vMotion IP address is 192.168.11.31. And for my ESX03, the IP address is 192.168.11.41. Okay, so I'm going to click Next. And in the storage traffic screen, if you have a VLAN ID for your vSAN traffic, you can check the option Use VLAN. Like I said, I don't have a VLAN ID, so I'm going to uncheck this option, and I'll keep the IP protocol as IPv4. And under IPv4 configuration for the IP type, I will select static IPs, and I'm going to specify the IPv4 address subnet mask for my vSAN VM kernel adapters on all the three ESXi hosts. Now, if you see here, you don't have an option to specify the gateway IP address for vSAN network because the wizard will take the gateway configured in the default TCP IP stack. So for my ESX01, the IP address configured for my vSAN VM kernel adapter is 192.168.12.21, and it's a class C subnet 255.255.255.0. And I'll click autofill. And again, the number is not continuous in my lab. And for ESX02, the IP address for vSAN VM kernel adapter is 192.168.12.31. And for ESX04, the IP address is 192.168.12.41. So I'm going to click Next. Now in the advanced options screen, you have options to enable or disable host failure monitoring, virtual machine monitoring, admission control, and set the admission control policies. Now you can also specify the vSphere DRS automation level and set the migration threshold. And under vSAN options, you have options to specify the deployment type, whether it's a single site cluster or stretch cluster. In my case, it's a single site cluster. You can also enable or disable encryption and specify the KMS cluster if you have enabled encryption. You can also enable or disable deduplication, compression, configure the fault domains, and specify the large-scale cluster support. Under host options, you can enable or disable lockdown mode. You can specify the NTP servers. So I'm going to specify my domain controller as the NTP server for the hosts. And also under enhanced vMotion compatibility, you can either enable or disable EVC and specify the EVC mode. So I'm going to click next. Now in the claim disk screen, you can specify the cache disks as well as the capacity disks that will be contributed to the vSAN data store by the two new hosts which we have added. As mentioned previously, for my lab environment, all 20 gig SSD disks from the hosts will be selected for cache tier, and all 200 gig SSD disks from the host will be selected for capacity tier. All right, I'm going to click next. Now, I don't need to specify the proxy settings because my vCenter has direct connectivity to internet. So I'm going to click next on the proxy settings screen. Otherwise, you can check the option configure the proxy server if your system uses one, and you can specify the host name, port number, username, and password for your proxy server. In the ready to complete screen, you can review the settings and click finish. And when the vSAN configuration completes, it is always recommended that you run a vSAN health check and see if you have any errors. Since it's a lab environment that I'm working with, there would be some errors which I can ignore. Lastly, I'm going to show you how to apply the vSAN default storage policy to the vCenter server VM. So I'm going to right click on it and I'm going to navigate to the VM policies, and I will click on edit storage policies, and in that I'm going to select vSAN default storage policy to apply it to the vCenter VM, and I'll click OK. And I also mentioned that you need to complete your distributed switch configuration the way you prefer. In my case, the distributed switch only has two port groups, vMotion and vSAN. Also, the uplinks are named with default names, and nicknaming can be inappropriate. So I prefer to make some changes with my distributed switch, but in your environment, this would be different based on your environment design and needs. So some of the things which I typically do is migrate management network VM kernel adapters from standard switch to distributed switch. I'm going to add additional DV uplinks and categorize them based on the network type. And I'm going to create additional DV port groups for virtual machine network, and I'm going to configure the teaming policy for each of these DV port groups. Now, this concludes the step-by-step instructions to create a new vSAN cluster while deploying a new vCenter Server 6.7 Update 3 appliance. Hope this video has been informative to you all, and I thank you for watching this video.